Okay, sorry for the delay. The camera in the other classroom failed to start for whatever reason, so we had to change classrooms. All right, so today, as I said in my announcement, I want you to have a pencil or pen and some writing paper. Okay, what we're going to be doing is some practice exercises. I'm going to ask a question and then you write the answer. Just practice. I won't be able to check your answers. Normally in a face-to-face, I can see what you've written. But please don't just sit back and wait for the answer. At least give it a try. All right, so we'll start off. Get a little light on here. Okay, so going back to, going back to the previous chapter on aromatic compounds, I'm going to start off with some nomenclature. Okay, I'll write the question, and I'll pause for a few seconds to give you a chance to write the answer, and then I'll write the correct answer. So again, at least try, even if you get it wrong. That'll benefit you much more than simply waiting for the answer. All right. Okay, so the first one, okay, we'll start off with some nomenclature. And I want you to draw 2,4-dichlorotoluene. 2,4-dichlorotoluene. The other disadvantage is I won't be able to see if you're done writing. Okay, the answer is that's 2,4-dichlorotoluene. Okay, the next one is 2-phenylphenol. Okay, 2-phenylphenol. All right, this is phenol. Okay, and then phenyl means that we have a benzene ring as a substituent. that's 2-phenylphenol. This was formerly the active ingredient in Lysol. Lysol uses a different formulation now. Okay. Okay, so draw the structure of 1,4-diphenyl 2-butene. Okay. Butene, that means we have a triple bond, and it's between carbons 2 and 3. Okay, so that is, that's 2-butene. And then phenols are benzene rings as substituents. And we might also see this written as pH. Okay, so pH is an abbreviation for benzene ring as a substituent. Okay, 3,5-dimethoxyaniline. Right, aniline is aminobenzene, or it's benzene with an NH2 group. It's understood that the NH2 is on number 1. Okay, methoxy, that's an ether group. CH3. So that's 3,5-dimethoxyaniline. name this compound. This is 4-nitrophenol. Nitrophenol. Name this compound. Okay, the lowest set of numbers would be if we started down here at the bottom. This is 1, 2, 3, 4. And so we could call this 4 isopropyl. 1, 2 dimethyl benzene. Okay, in this compound, the nitrogen is position number 1. This is an example of a heterocyclic aromatic compound. Right, the correct name is 3 nitro purity. Free nitro purity. Right, this one is called naphthalene, NaPHALENE. Okay, so this is one it's a white waxy solid. It's been used in mothballs. Right, now we're going to look at some products of reactions, and I'll also give you some questions where you have to supply the missing starting material. Okay, so we'll start with just some simple monosubstituted benzenes. All right, so starting off with benzene, show me the product here. I use chlorine and FeCl3. Okay, just the organic product is sufficient. Okay, I'll give you a hint. The byproduct is HCl. All right, the answer is chlorobenzene. Okay, you might see this just written as H2SO4, but it's they actually use an even more concentrated version. Okay, so what is the organic product? Okay. This reaction is called sulfonation. Or drawing the full Lewis structure. We would have a sulfur, double bond oxygen, OH. So this is a sulfonic acid. It's called benzene sulfonic acid. Right, and the byproduct of this reaction is HCl gas. This is called Friedel-Crafts acylation. Your product will be this ketone. And that's the organic product, and then HCl is the byproduct. Okay, so this is 1-ethyl 3-propylbenzene. And if we heat this with concentrated KMNO4 solution, strong oxidizer, what do we get? This is what's called side chain oxidation. Right, and notice here that it's broken off the chain and just left the last carbon, and that's been oxidized to a carboxylic acid. Okay, this reaction could be accomplished also if we had a ketone. We'd still get oxidation. Get the same products. Okay, the main limitation of the side chain is that there has to be at least one hydrogen here at the benzylic position. Okay. So if we have tert-butylbenzene, the terbial group wouldn't be oxidized. Right, so if we have a terbial group here, we don't have a hydrogen here, so that wouldn't undergo oxidation. Other groups that won't, that are not affected would be things like nitro groups. If we had a nitro group, that would be affected. Or if we had a halogen, that wouldn't be affected by the oxidation. Right, besides KMNO4, we can also use chromic acid. Okay, both of these will oxidize the side chain. Okay. What do we get when we oxidize? Or not oxidize, react benzene with nitric and sulfuric acids. What's the product? You do a nitration in lab. Okay. I think it was what, bromobenzene. Okay, so this would give you nitrobenzene. All right, the active electrophile okay, this is the electrophilic intermediate. Okay. And if you take a look at the sampling, okay, this is a free answer for you for one of the questions. Okay, what is the intermediate? Okay, what is missing? What do we need to convert benzene to bromobenzene? Okay, you will also need a catalyst for this one. Okay, so what you need is Br2 and FeBr3. Okay, iron 3 bromide or ferric bromide is a catalyst. Okay, what do we need to convert benzene into ethyl benzene? My product here is HCl. Or at least that's one way. Okay. So you could use chloroethane and aluminum chloride. Okay. Next, I'm going to test your knowledge of orthopara and meta-directors. Right, so this is methoxybenzene or anisole, and it happens to be an activating group. So you notice I don't even need a catalyst. This will proceed at low temperature almost immediately. Right, all activators are orthopara directors. So what we'll get. Right, so we'll get two products, ortho and para. Starting with chlorobenzene, will react with bromine and iron 3 bromide. Okay, and here's a hint. We have lone pairs on the chlorine. Okay, so chlorine is an orthopara director. Okay, so we'll get two products. Chlorine and the other halogens are orthopara directors, but they are also deactivators, right? So compared to benzene, this reaction will be quite a bit slower. Halogens are the exception. They're the only deactivators that are orthoparadirectors. Right, this is benzoic acid. And we'll react it with nitric and sulfuric acid. I'm giving you enough time. Okay. Right, because carbon from the benzoic acid has a partial positive charge, it's going to be a deactivator. And so the nitro group will end up meta. And this will be much slower than nitrating benzene. Okay, so it's a deactivating group. Let's do chlorination. This one's a little bit trickier. Okay, so both the methoxy and the methyl are activating groups. The methyl is a weak activator. The methoxy is a moderate activator. Okay, the more activating a group is, the more influence it will have. Okay, so both of these are orthoparadirectors. The para position is blocked, it's occupied already. Okay, the methoxy group is more activating, and so it will have more influence. Okay, so we can't do para, so we have to do ortho. So this would be the product. perhaps acylation. All right, both the methyls are ortho-para-directors, and substitution is most likely ortho to one group and para to the other, here or the equivalent position here. It might be possible to go ortho to both of those, but there wouldn't be much room between those methyls. So if that happened, it would be a very minor product. So because of crowdedness, I would not expect much substitution here. All right. So these are both ortho-para-directors. So we'll get substitution ortho to one and para to the other. And of course, as I mentioned, this would be the equivalent position. It would be the same product. Ortho to this, para to that. Okay, we wouldn't expect substitution here. That's meta to both groups. Okay, I'll preface this by saying this is also a trick question. Okay, we're just about out of time. Okay, the answer is no reaction because this ring is too deactivated to do an ortho to do a pre-craft. Okay, anything more deactivating than a halogen will not allow the pre-crafts to go. Okay, other reactions such as nitration, halogenation, and so on, sulfonation, those can take place on deactivated rings, but not pre-crafts. Okay, so our time is up, so I'm going to go ahead and end.